Good morning to all. In the last class, I taught you about one of the most important problem in the balancing of rotating masses, right? In this class, I am going to teach you about one of the most important problem in the balancing of reciprocating masses. Read the problem. A single cylinder reciprocating engine has speed 240 rpm, stroke 300 mm, mass of reciprocating parts 50 kg, mass of revolving parts at 150 mm radius. 150 mm radius. If the two-thirds of the reciprocating parts and all the revolving parts are to be balanced, find the balance mass required at a radius of 400 mm and the residual unbalanced force when the crank has rotated 60 degree from the TDC. Right? Here they mentioned the mass, revolving part mass is 37 kg. Right? Then write the given data. What are data given? The problem, so they given the speed, that is 240 rpm, and they given the stroke 300 mm. It's available in the mm, so we need to convert it to meter, divided by 1000, 0.3 meter. The mass of the reciprocating parts, that is 50 kg, and mass of revolving parts 37 kg. Reciprocating parts is the reciprocating part mass is the m. Revolving part mass is the m1. Okay, right? Then they given the radius, revolving part radius, that is r equal to 0.15 meter, that is 150 mm. Then they given the condition, the two-thirds of the reciprocating parts and all the revolving parts are to be balanced. That is the condition, two-thirds of the reciprocating parts and all the revolving parts is to be the balanced condition. Right? Then we need to find, what we need to find? The balance mass required at the radius of 400 mm. Okay, right? And residual unbalanced force when the crank has rotated 60 degree from the TDC. 60 degree from the TDC. These two conditions we need to find, right? How we can find these values? Which type of problem is this? The problem itself, they given the reciprocating engine has a reciprocating part as well as revolving part. Both parts are available in that system, means this problem, that problem comes under the reciprocating mass, balancing of reciprocating mass. Okay, right? Then how you can find these values? First I am going to find the balance mass required, balancing mass required. For that we have a formula, capital P small b is equal to m1 plus cm into r. Right? Here we have all known values one except the capital B, that is the balance mass required. That is the balance mass required, right? So we can substitute all the remaining values in this equation and find the value of balance mass required, right? That is the value will be 26.38 kg, right? After finding the value of balance mass required, we need to find the residual unbalanced force. At the crank has rotated at 60 degree from the TDC, right? The formula for finding the unbalanced force. Formula will be m omega square, the square root of 1 minus c the whole square, cos square theta plus c square into sin square theta. This is the formula for finding the residual unbalanced force, right? Here we need to find the value of omega first. For that I am going to write the formula omega equal to 2 pi n by 60. Here we know the value of speed, so we can substitute those values here and find the value of omega first. The value will be 25.14 radian per second. After finding the value of omega, we need to substitute all the values in this unbalanced force equation. Residual unbalanced force equation, and substitute all the values here and find the value of residual unbalanced force, right? The value will be 2849 Newton, right? In the next class I will teach you about one of the most important problem in the reciprocating mass. Thank you.